Good evening. Today we'll be discussing about the map visualizations, and this is the generally the last exercise which is carried out in normal GIS analysis. So we'll look into the different map techniques and how map is will be created and what are the different ways of classifying the data sets to generate a map. So those are the few options which we will be seeing in this lecture. So let's first discuss that why do we need a map? So this is a simple map which is showing different sections through a web. And if you ask any kids, or maybe let's say 5 years kids, then what do you see in this picture? So that person or that kid may say that I'm seeing some red, white colors and blue colors and so on. So it means like the map is containing few of the color informations, and there are also someone may say that we are also seeing the lines and few words which is being written on this picture. So this is the basic conclusion which will make any kids is going to make whenever he is going to see this particular picture. Now, in the next stage, if I ask probably the someone who is, let's say, class 10 students or maybe undergraduate students or up to class 12 who is looking into these pictures, then he may say a lot of other information which he or she can observe. Like he will say that there is a lot of lines which is darker in color compared to others, and those lines are generally the roads. The blue lines are basically the river channels, and the other green areas are basically the can be a forest areas, and the red colors can be a built up or city areas. That kind of answers we may get in. So, and then when you ask anyone, maybe undergraduate or postgraduate student, that what do they see in this, then they will be, even someone will be able to explain that this is a city having a road density higher. There is a city center which is actually intersection of the different roads and so on. So those kind of additional informations can be brought in. So, with all these statements, what we see is that basically the maps is going to give you an representation of different geographical data, and those representation has to be in effective and efficient way. So it's basically provides, it's basically a tool which lets you create effective and efficient representation of the geographical data sets. And basic reason for this representation is that the person who is going to read this data set, he or she should be able to uh, get or understanding of the area, not only in terms of what is where, but also in some cases to understand what's the spatial pattern distribution, what is the relationship. Then for example, let's say we said that the city center is going to have an basically the intersection of the roads from multiple roads coming from outside. So those kind of informations or patterns may be existing. So those things can be understood if we properly represent the geographical data sets. So basically, at first level, at first level the maps can be considered as a tool to efficiently or effectively represent the geographical data. But at next level, it can also provide a certain spatiotemporal patterns, their relationship. In some cases, if we use the time series maps, then we can also understand that how trend is there. Maybe like if you have multiple time period map of same areas, then we can see the evolution of the city and so on. So it means like the map is an important component to look into both pattern relationship trends and as well as efficient representation of the data sets. So in general, if I talk about the general objective of any map is just to find out or tell where is what. So it means like in this pictures, if somebody asks like where is the temperature 30 degrees centigrade, So by taking a reference to the legend on the right hand side, we can look into areas, and those areas are basically a southern states, especially in the region of Karnataka is the basically the state where, or maybe we can also say the Andhra. These two states are actually having a temperature distribution which is around 30 degrees centigrade. If somebody says that what is the temperature in the north of some state, then that can also be seen, and we can say in the north generally the average temperature is what is being observed is 44 and 45. So basically map gives these basic informations, and which is actually a part of the first objective of map, that is the representations. If we include certain amount of time, then in those cases we can generate multiple snapshot of informations. So like in this case we are having basically the different seasons and their time differences from the mean of a long time average, and based on that the map has been, or the information has been presented in this case. So there are two areas which is being shown in this case. But in general, if you look into the red and blue areas, so it says that the red areas are the regions where the temperature differences has been observed above the mean of long-term average, in this case the 10 years. And there's an also some places where we are seeing the decrease in temperature in when we take the average temperature in different time horizon. So that's, so once we have such kind of temporal data sets season wise, then we can look into our answers not only where and what, but we can also say when is the lowest temperature observed, or the when in is there any specific season in which the lowest temperature has been observed or lowest temperature anomaly has been observed, and so on. So the map representations also lets you to do a query or try to find out the information based on basically a single time. And if you combine multiple times, then we can also do a kind of temporal analysis, and based on that we can give answer to certain questions like we said that when is the minimum temperature, or in which season is the minimum temperature anomaly is being observed. So in general, if you look into any kind of geographical phenomenon or data sets, we are having two major component, that is the where, which is actually the geographical locations. Those locations may be a point one, maybe a grid, it may be a polygon, or it may be line. Any kind of things can be there which will have its coordinates and the positions, associated positions with it. And each of those geographical representation, or in other word we can also say the geometrical representations in geographical coordinate, will also have certain additional attribute information. Like in the last two maps, basically we observed that the attribute informations were actually the temperature. So those attribute informations will let us to find out the informations regarding what, and generally we call it the theme or thematic informations. And in the, if we combine these two with the certain amount of time interval, and we generate a maps on regular time interval, then we can cover the pattern which is being observed in a temporal domain, and that gives a kind of understanding of the whole process, trend, and other characteristics. So the patterns can be either only on the basis of association of the attributes in a grouping form in a spatial domain, or those grouping forms may also change with the time. So if you combine these two, we'll be able to get the complete spatiotemporal representation of the informations, and that's how we will get the higher level of pattern or understanding of a particular area. So these are the three basic corners on which the geographical data sets is being based on, and those information is actually is being represented in the form of map. So before making map, we have to make certain distinctions that or try to understand if you know or you have been assigned to carry out the activity of generating a good map, then we have to understand what exactly what does the or what is how will you define that a particular map is a good one or a bad one. So this is just an example which is showing the two different representation of geographical phenomenon. So in first case, we are seeing that single theme, which is temperature, and that has been spread across, is being represented, and there is a clear cut boundaries which has been defined on or had been put on the top of the thematic layer, and based on that we can see the how the temperature is distributed across in the area. In the second case, basically, so that's actually a good map representations. Where in case of second one, we can see there are a few boundaries. There are also a kind of distinctions of those boundaries in terms of separate colors. So that shows a kind of special emphasis. Then it is also showing certain area in brown and green color. So that also highlights that. Or that indicates that the map user or the map maker expects that the user should mostly focus on those red and green area predominantly compared to the whole areas, and that is being represented. So it's basically you are trying to use the different uh, tools or the graphical tools in terms of how do you fill those polygons, that is color, and as well as how does the polygon is represented, and to get an effect that which is actually more dominant or prominent compared to the other lines, like in this case thickness of the line and corresponding colors has been used to showcase that this is the basic objective, or the different polygons should be represented in the foreground compared to background. So this is just an example of a representation of the good map, where the other example, which is actually a bad map, is being shown in this case. So in this case, what you are doing is you are representing the whatever information which you're having. Like in this case, a lot of point data sets is available, and all those data sets has been represented in the map. So in this case, what happens is whenever your end user is observing this particular map, so he or she may be overwhelmed with the information which is present in this case. Like there are a lot of points are there, so user will first get confused why there are so many points are there. Then in some cases he or she will also get confused that why those patterns are somewhere at high density and the low density points are there, what is the purpose of those points are there. Some places those icons has also been provided with questions marks, so that indicates that there is a missing information, so those informations are not available. So even though the information representation in this slide is that you're having lots of informations, but when it comes to the point of understanding of information or geographical information from the end user or map reader's perspective, then it is not able to convey the overall informations. So if that kind of scenario arises, then we can easily categorize them as a bad maps. So in this case, we have to look for some better way of such points representations in a way so that can preserve the information whatever the map maker or the cartographer wants to convey, but at the same time the information which is being used to represent this map should also be a lesser one. So this is basic and objective which we should keep in mind, that whenever we are creating any maps, the information has to be crisp, it has to have a lesser amount of informations, and summarize as much as possible in terms of representations, so that the confusions will be lesser to the end users. And there has to be a kind of pleasing representations. In some cases, if you want your users to have additional focus on certain areas, so we can look for a certain amount of foreground or background separation techniques, like the color intensity or maybe a thickness of the colors that can be used. So those are the few tools that can when you use it effectively, then the final map representations will be a good one. So let's now summarize, and this slides basically talks about the or summarizes the basic steps or the questions we should look into when considering a good map. So whenever you want to create a good map, then in those cases we have to look for certain amount of questions, and those questions should be answered appropriately. For example, in the first case, we say that what is the motive or intent, or maybe in some cases goal of the map. So why do you want to create a map? Is there any specific purpose? Like in the previous cases we have seen, we wanted to represent the temperature distribution across different state in India. So that's the representation. So in this case, the representation has to be very well defined. You cannot simply say the map objective or the basic purpose of the map is representation of temperature. That is not sufficient. We have to elaborate a bit more. We have to correlate it with the specific locations and at what scale. So in this case, we are just talking about the state level information. So at what scale your basic map has to be represented. That particular motive or intent has to be first identified, and then we should move ahead. So this is very important aspect, that in your GIS, your data sets may come from multiple sources. Someone may have some of the sources input. You may be coming from the data source which will be at, let's say, a few thousand, one is to few thousands, or maybe 10,000 or 5,000 scale. Some of the information can come run from 1 is to 1, 1 is to 100,000 scale, and so on. So those are the multiple input which may be there inside a GIS solutions. But after the interactions of those different layers which may be coming from different scale, we get a final output. So we have to first make sure what is the best representation of that scale representation of that information. So in this case, it is not that vector raster cases, because in some cases you might have heard that the vector data sets are a kind of point line polygon cases. So it means like you can just zoom in, zoom out, and the continuity or smoothness of those lines will be there. So in that case, someone may argue that let's say you have created or digitized the topographic maps from few sources, or maybe some of you might have got the map information from Survey of India. So in those cases, and that scale of that input map maybe, let's say, 1 is to 50,000. Since you got those data set and you converted them into a vector, so someone will say, oh, vector is a line polygon. So simply zoom it and you can get the information of 1 is to 5,000 scale. There won't be any distortion which is expected in the raster data set. But that is not true. The reason for that is the informations what is expected to be present at 1 is to 50,000, or in other sense, all those features which can be visible or which will be visible, and as well as in some cases, even though some of the feature may not be visible but important, which needs to be represented in a map scale, or at a particular scale, that has to be represented. But as you decrease the scale, or then in those cases there are some additional information which has to be taken into. For example, let's say if I create a map at 1 is to 50,000 scale of a particular city, but as soon as if I want to represent that information is 1 is to 5,000 scale, then in those cases The road will no longer be a line, but it should be represented as a kind of polygon. It should have a proper width assigned to it, and so on. So it means like the representation of the map is very well embedded into the questions that what is the scale and what are the information which you want to showcase. So this purpose and objectives has to be quite clear. Once you have defined that from the map creator point of view, then you have to also accommodate the end user's perspective, or in other sense, to address your audience. So basically, I need to understand that who is going to read this map. Is this map is going to be used in your mobile phone, or is it going to be used in a paper form? So and so on. So accordingly, the based on the reader, the end user reader, and the environment in which that particular map will be used, will help you to understand the audience, and accordingly a proper appropriate technologies can be used. For example, if you think that your end user is basically a map reader who will be having all these information in a form of paper. So in that case, paper becomes a platform. So it means your representation has to be, and all your technologies should be dealing with proper representation of the information, or effective and efficient representation of the informations in a paper on a paper. But if your same map is being has to be represented in a mobile phone, then you have to consider that mobile screens are quite small. So means a lot of other important things which you see in general map, for example, the directions or maybe legend and so on, those things will be effectively will be hidden or docked in a particular area. So once user wants to know, mostly in those cases he or she is going to open that dock area and correspondingly can get an informations. The other important thing is like you also need to understand the behavior. So in case of the person who is using the mobile maps for the representation of the data sets, so he or she will be quite well aware that what are the information which he is looking, and accordingly those information will be displayed or selected. For example, let's say whenever you use a Google map, so your basic objective is to find a road. You don't bother about is there any forest area is there or not, or at least where a large amount of a large number of people may not be interested the other feature which is shown on the map, apart from just seeing a blue or gray line and getting an idea or answer that how much time does it takes. Apart from that, what the other information that people are in the map represented in a Google map, the most of the user may not be interested in. So that happens because users, whenever he or she is using any kind of mobile map, that intent is quite clear. So your user knows that what exact information he is looking in, and accordingly he would be doing a search activities, and based on that he'll be carrying out the representation of the data sets. The next question is, so once you have decided, you understood your audience, and you fixed your purpose and representation of your data set, then you have to look for how those informations can be represented in an appropriate environment. And along with that, in some cases you also need to look into that how we're going to generate those information. So it's basically, if your main data set is 1 is to 50,000 and somebody says that I need a map, let's say for example you're having a city map which gives you all the detail, or topographic map in general term of a city, and people will say okay, I need an road map which can be represented at, let's say, 1 is to 10,000, and for that he or she might have given you a road network which is represented in a city topographic map at 1 is to 50,000 scale. So in that case, you'll be some of your task may be that you need to extract those lines or the road from the map, and then that map can be represented as a 1 is to 5,000. So that particular things, whenever you are carrying out such activities, then you have to know the constraint, or you have to understand, as I was telling at the beginning, but that in at a higher scale certain information may not be, or there will be a lot of additional information which is expected to be present, rather than just generalized and important features which we'll see at lower resolutions. So in that case, what is the sources which is available? Sometimes we also need to look for the resources. Let's say if you are interested in generating a paper-based maps, you also need to consider the lead time which it will take to a printer to get or generate those paper maps, and so on. So once you have these informations, audience and objectives, based on your purpose objective, your information should be available. Then finally at the end we use certain cartographic design principles, and those principles basic objective is to represent effectively and efficiently the informations, or the geospatial information which you have collected on a map, and which can be used for communicating the your analysis to the your in audience. So in that case, if you have to use effectively, the example of bad maps and good maps which you have seen, so a lot of unnecessary information should be dropped, or in some cases if it is still required, so we have to look for a kind of a better way of summarizing those informations, so that it is crisp and neat and clean, and that those kind of objective, or the activity comes under the cartographic design principle. So there you do some kind of important or prioritization of the feature which you want, then summarizations and so on. So all those are actually a part of cartographic design principle, which actually will help us to generate a good map. So this is the bad map which we have already seen. So in general, whenever we are having a cartographic data sets, so as a part of cartographic designs, we generate all those geographical data sets, maybe in form of shapefile, geodatabases, or in some cases the paper maps and so on. That has to be represented with the all those four steps, so that it can be summarized effectively, can be represented, and this whole process or activity is actually called a cartographic visualization process. So under that, we take all the geographical data, and finally we represent the information in a form of map. One important thing which we need to consider in today's world is that in today's world the map is not only is being represented only in form of two dimensions, but nowadays we are having a certain maps which is also having a third dimension associated with it. So in some cases we'll be having a tactile based profile. So means that there will be a maps which will, for example, there are a lot of places when you find it out that the terrain surface can be basically can be represented in a third dimensions, and that can be printed using different 3D printing technologies in a form of maps, so giving you a kind of idea about the area. So those are actually a three dimensions maps which is there, which is actually tactile maps, so means that you can touch them. And there are also virtual maps, so like the Google Maps, or maybe some other 3D maps, Terrascan and so on. So those are the different maps which is available, and those visual or the virtual maps basically also provides the 3D information maps. So whatever currently we are discussing is just discussing the representation of information in 2D map in 2D. So it means like it will only have X and Y as in terms of positions, and there may be a lot of thematic informations which might be there. So in general, if we look into a visualization process, so whatever questions which you asked, and based on that, we carry out a kind of cyclic activities. So basically, whatever information we have to look into what we want to represent as a cartographer according to the our design basic design requirements, and then based on your audience or the users, so we say we whom to whom we need to represent, and from that perspective your map has to be evaluated, and we have to look into that is those information is effectively is being extracted from the end user. So that's basically the information retrieval is how effective that is. If your information is highly effective, then you can say that your representation is a good one. If your representation is not good one, then you have to reevaluate. Maybe you have to use the color combinations. Maybe you have to use certain contrast enhancement. Maybe you have to use certain other cartographic tools like thickness, patterns, and so on. So those are actually also called visual variables. So appropriate visual variables has to be used and evaluated for a better representations or effective representation. This whole process is actually a part of visualization process, and with the advent of different computer systems, now this we can call them that this is basically a kind of iterative process. So we can quickly create map, do some kind of initial evaluations from the end user's perspective. Maybe sometime we can also evaluate, we can involve some of the end users and get their feedback, accommodate them, and correspondingly we again redesign the whole process. So this whole circle is actually a part of visualization process. So in cartography, you have geodata sets, and there will be a certain measurement scale. So your data set is effectively can be grouped into two major categories, which is basically a nominal data sets, and as well as you'll be having the continuous data sets. So nominal data sets are nothing but which the data sets which can only be used for differentiating the name. For example, some of you may have a shape file containing the different states of India. So in that file, you'll see only the state names, or maybe in some cases the state ID and names. So those state ID and names, is only objective is to showcase that each of those states are having a separate boundaries. Apart from that, you cannot use the data sets more than that. So those are actually called a kind of only the nominal data sets. Similarly, you have other different kind of data set like ordinality, which is nothing but a temperature based data sets. So all these geodata set has to effectively represented in such a way that whatever the measurement scale was there, was it in nominal, what was it in ordinal, what was it in ratio forms, and so on, that inherent properties of data sets should also get communicated back to the end users, and that's how the there actually comes the cartographic design process, or the linking of those design of visual variables with an appropriate representation, so that their properties or percentage perception properties enables you to extract the measurement scale or the scale on which the actual data is there. That should be should be visible. So once you're satisfied those representations, you can stop the process. Otherwise, this loop continues and looks for the other cases. So before going ahead, let's see a basic representation of few maps. So in this case, we are seeing a few kind of maps. Again, these maps are a kind of specific purposes, and accordingly the map has been represented. So as you can see, these two maps are actually of the same area or same city, which is Udaipur. Only difference is there that in one cases you are covering the larger areas compared to the second one. So it means in the first case, the first one on the left hand side is showing the maps at 1 is to 25,000, where in second case the map is 1 is to 50,000. So it means the information which is being represented in, or the area which is covered in right hand side map is 4 times the area which is represented on the left hand side. That's the basic differences which you are seeing. But even if you zoom it at a particular place on area in a map and look in more detail, then you'll see that the information which is present at 1 is to 25,000, not all the information, all the same information is present at 1 is to 50,000 scale. So this is exactly which I was trying to say at earlier, that if you have a lower scale informations, so even though your GIS software allows you to represent those data sets in a continuous form, but there are some additional informations which may be present and that may not be visible in even though if you are just simply zoom it, or that is a kind of you can think of is an equivalent of that is a kind of optical zoom. So if your input image is having an coarser resolution, even if you zoom it too much, you will not be able to see any additional information. So same also goes with the topographic maps. And these topographic maps have a very well-defined objective. So generally, the maps will have a lot of dominance in terms of red colors, and those red colors actually represents the man-made features. So basic objective of this topographic map is just to understand or link or associate the map users with an appropriate to one geographical areas. Or in other sense, if you look into if you want to bring out the equivalence of this topographic base map, then you can consider them as an older time GPS. So nowadays, in your mobile phone, you find coordinate systems. So you just switch on your map, and immediately there's a blue color dot is being shown, so that indicates that where exactly on this map you are there. But in earlier times, those kind of privileges were not there. So what people used to do is take their map, open it up, and then they will start looking for some prominent features. That is, for example, in some cases, important landmark roads, high buildings. In some cases, and they can also look for a kind of terrain features like any peak or maybe a forest area or maybe a water bodies and so on. So now, based on those important feature which is available in the map, user used to look for an association in the open environment, and then accordingly he or she used to orient those maps and try to navigate and so on. So in that sense, topographic maps basic objective is to represent all the important features so that your users or your end users should be able to appropriate link the locations with the surrounding. So that's the basic objective, and generally these maps are now being available in from in a UTM grid systems from Survey of India websites, and there also you can get those topographic base maps. So now let's move on to the important aspect of that. How do we represent the maps, or basically whenever we are talking about the map representation, so what do we mean by that? So this is just an example of different wards of Dehradun city, where we can see that there are a lot of polygons are there, and those polygons has been colored. So those coloring of those polygons has been done according to some criteria. So those criteria may be very simple, based on certain grouping and classifications, or those criteria can be very complex processes or very heavy geostatistical tools and so on. So you can group them together, and finally you will arrive a kind of classes. So let's say some of those GIS analysis has been carried out, and based on that the map representation has been done. So in this case, the for the time being, just consider that this data set is only present in or having these colors, and some information is present. So that's the only things which we will consider for the time being. Now, the same informations, if I the same thing, whatever is, or the same data set what is being represented on the left hand side has also been replicated on the right hand side. So as you can see in this case, both the maps or both the data sets represents the same informations, And if you start mapping, so there will be see a kind of like, for example, the darker brown color is actually equivalent to all the areas which is having a green color, and the orange color are almost brick red color. Similarly, we'll having a very light red tone or a kind of brick color is having correspondence to the a kind of pink color and so on. So we can find out the correspondence, and we can easily say, but both the things is being both the maps represent the same informations. But from the end point of view, if I ask you that which one of these things or which of these maps is seems to be comfortable from the end user point of view, then in those cases probably the second map will be coming on the top compared to the first map, or the right side map will be winning in compared to the left side map in terms of aesthetic representation, neatness, and so on. So as you can see, even though the information might be same, but the way you use the colors is very important, and that can be seen in this case. So in this case, basically it represents the if I add it the additional informations, that in this case the all these two maps actually represents the population density map of each of those wards. So it is quite clear that in some cases that relative orderliness, or I should say the which all the area which is having higher density compared to lower densities can be understood without having any other legend. So your user automatically will be able to pinpoint that which all the maps or which all the areas or which of the wards are having a higher population density compared to the other one, without even looking into legends and so on. So this gives you a kind of ordinality importance if your data set is having a characteristic. So that was the thing which you're talking about, like then at the scale level your informations or the population density is expected to have a certain amount of ordinality, and those ordinalities has to be also communicated to your end user. So this basically shows that in the second one, where the intensity of the color is only being varied compared to using a lot of variety of color, is a better way of representing your data ordinality. So this is just an example where shows that how how should we apply an effective cartographic tool, which is nothing but colors, to effectively also communicate back the end users the actual input data set which we are having. So now we'll ask. So there are a lot of different ways of representing the information. So let's say once we understood these colors, now there might be a certain questions that is there any other or better way of representing these information. So like in this case, as we can see that there are two different maps. In first cases, each of those polygons has been given colors, unique color in term of intensity of the colors, and where in the second case there has been a grouping. So even though in the first case there has been a 60 different shades of red color has been used, but if your end users will start reading, or if you try to interpret, so probably you'll say no, it's not correct. In the left side map is only showing 5 or 6 color. How do you say that it is having a 16 or 60 different colors? So what it means is that even though your data set is having or your data set characteristic has been carried out, but there is an inherent grouping of the data sets based on the color intensities, and that tells that your informations which is expected to be wide as 60 different variety of the informations is not no longer getting communicated to the end user. So he or she is maximum effectively showing maybe 5 or 6 colors on the left hand side. So considering this association of the colors or nearby colors and as well as your value in your data set, so both of them work in a tandem, and based on that what we do, we carry out the grouping of the data set, so which we call it a classification. So in the second case, we do appropriate classification, so it means that we do a grouping. So all the data sets has been grouped together. So all the grouping over here means that all the similar values should be put into a single class. So there's a question, or there's a sentence which is called all the values which is of similar type. So what is the meaning of similarity? So we'll look into a few of ways of representing the similarity, and this similarity basically helps us to create classes. So there might be a multiple way of defining those similarities, and based on that the grouping of the or the classes can be created, and then we can represent the informations. So this process is actually called a thematic map data classification. So generally whenever we do any kind of thematic map data classifications, so there will always will be a trade-off. A trade-off in the sense that if I use two less classes, let's say I group all the data set which you have seen earlier in a single class or a single color, then it means that I am losing the detailed information which is present in different polygon. At the same time, if I do a too much elaborated and each and every polygon has been represented like the in the previous case on the left side map which we saw, in that case what happens is that there is too much information is present, and accordingly the problem is that there's an overburden of informations. Along with that, there's a lot of other resources. For example, in the if I'm using 60 different colors, so it means that I'm using 60 different color representations, so effectively meaning that I'm using larger resources compared to if I use just six colors to represent the information. So all this is being done in a grouping is being done based on these trade-off that do you want to maintain or contain the individual data sets, or do you want to go for a generalizations or group them into together. So this particular aspect is being taken care of in thematic data classifications based on the historical or histogram representation of your data sets, and that finally gets represented especially in the maps, so that we should have a grouping of similar values. And then once we have a grouping of similar values in the same group, so it's like the way in the stats classes, maybe in 910 we create a class interval or a group. Same way is the case over here, but only difference is that there might be a multiple ways of creating those group based on nearby assignments. And then finally once we create those groups, then we simply assign them colors according to the base data characteristics. So if your each of these groups are expected to be having some kind of ordinality, like in the previous case we saw the population density still remains or maintains the ordinality, so accordingly the ordinality influencing or the cartographic tools which is in the last case was intensity is the color that should be used. But if your data set is not having any kind of grouping ordinality, it's only for the representation of like different states and so on, then we can use multiple hues and so on. So those things can be carried out at later data sets. So in some cases always there will be a questions that when we say that there's a similarity of the values, so how do we define that, how many classes do we create? So generally, the thumb rule is that evaluation is basically the thumb rule for evaluation is that if you has too many classes, it is quite confusing. If it is having a less number of classes, then pattern or the special pattern gets erased. So in general, if you create any kind of map which has to be consumed by very large masses, so means your objective is that your end user is anyone on the earth on the earth. So in this case, maybe at baby which is having 6 or 7 years of old, or maybe postgraduates, or maybe expert in your area, all of them should be able to understand what you are trying to represent. So in those cases, general thumb rule is that you should have 4 or 5 classes, because in those cases it is easy to associate and look for the grouping of data sets becomes quite meaningful, and that can be interpreted by a large populations. So let's now start looking into whenever we say the nearby a grouping of the data sets. So in that case, there are tools which is available in different GIS software, or if you don't have a software, then still you can do it using Excel and so on. So basically, there are the classes creations, or basically the class interval creation, which is actually a way to group the nearby values or similar values, can be done on the basis of standard statistical analysis. Some of them are which is available in quite familiar or already available different GIS software. For example, equal interval or natural break or quantile classification, standard deviations, and some cases we also use certain amount of series. For example, geometrical series or arithmetic series. So these are the few ways of creating the classes, and these are mostly applicable to interval and ratio data sets. So grouping is being done mostly for interval and ratio data sets. The nominal data sets is the grouping is not possible, because all the data sets is at the same scale, so you cannot do a grouping. So either you have to put all of them into a single class, or you have to say all of them are separate. In case of ordinality, definitely we can create the grouping, but that is only on the basis of order, and based on those order rank we can create it. But in general, the classification of the data set happens on the basis of basically the data set which is of interval or ratio data in nature. So let's look into a few of the examples. So these are basically, first one is the equal interval classes. So in this case, what has been done is that you take whole range of your data sets and you break them with a equal class interval. So means your data set class interval will be same. So it means like if you take two classes differences, in all of them is expected to be a same one, and based on that classification. So it's a very simple grouping which is being used in general statistics. You might have used it in class 9 and 10, where you might have been told to group the or your certain data sets to be grouped into a certain classes, let's say 5 to 10, 10 to 15, and 15 to 20, and such cases like that. So this is an equivalent to that only. So that's, we are creating a equal interval classes in this case. So in this case, what happens is that once you create an equal width, then each of these classes now may have a different amount of distribution, because it is dependent upon only on the range of your data set. So in some cases, if your data set is having too many, or one class is having too much or a large number of data sets, or in this case the polygons, all of them will be colored with the same color. For example, in this case we see a lot of polygons are showing in a white color. So it means in the first class, or the range which you're seeing, is the large number of polygons is falling into that. So the effect of that is that uh, the overall color table. So it means like you might have used 5 different colors, but in your final map you are only seeing dominance of 2 and 3 colors. So you are not able to see all the 5 colors quite effectively, and there's a very large area which is having of single color. And in some cases, even though you're trying to assign 5 different colors to a map, in your final map you may not have more than 2 and 3 classes and so on. So these kind of issues can arrive, and it's such kind of things should be used only when you want to emphasize that certain attributes or each of the second classes. For example, if you're doing a classification based on income group classifications, or maybe the number of people living in a poverty, or the number of people who are in a rich category, or such kind of things are there. So in those cases, based on per capita income and so on, you can group them together. So it means like whenever you want to emphasize that one particular group is better or relatively better or worse compared to other, and each of those groups are only different in terms of linear variation. So means your as your per capita income increases, one hypothesis can be made. Accordingly, the neatness of this particular area will also increase. Let's say this is the assumption. So in this case, it is expected that the each interval increase in interval, the corresponding values will be similarly increasing. So in such cases where relative comparison of the different group is needed, in those cases we can do an equal interval classifications. Now there's another classification scheme which is called a natural break. So these are the cases where you look for a kind of subgrouping. So means you expect your data sets to have certain amount of groups. For example, let's say if I collect the number of shops present in each of those in each of those wards, or in this case, the way we are having the number of people living in those wards, or the population density of those wards. So as we expect that at the core of the city, there will be a lesser size of the plots, or accordingly, the larger population density will be living at the core of the city. As you move away from the city, the number of people living in a particular or per unit area will be lesser and lesser. So in this case, we see that as we move away, there's a natural tendency of your data sets to be having a subgroups, and those groups and subgroups can be identified with the help of natural breaks, and that's what we can do it. We can create it into different classes. There's also a quantile classification. So in some cases, you may be interested in to find out that which one of them is falling in top 20 and which of these classes are falling in bottom 20 and so on. So that you can do an inter comparison of the areas and maps and so on. For example, at the south side of the ward, you see that there is a brown color polygon just adjacent to a white color polygon. So that indicates that highest population density is just nearby available to the lowest population density area. So that or the top 20% of the people are living in the brown area, or the polygon on the brown area in the southern region, and the to south of that particular polygon is we're also having people, which is actually a kind of basically a top 20 population densities and so on. So these are basically, and these are the areas which indicates that there has to be something specific about those zones, right? So it cannot be suddenly population density will be very high and that just one line is creating, and where population density suddenly has dropped in. So these kind of very interesting features gets elaborated, and that can be studied further, and we can look into why is it so and so on. So that helps also help us to do a lot of investigation in those areas, and we can come up with a lot of different theories and so on. So this is just an example of quantile classifications. The quantile classification, the way we saw earlier, there are also another classification scheme which is called standard deviation classification. So these classification techniques is being used whenever you want to bring out the contrast. For example, if you're having a GDP data of the whole India, and you want to say that in certain states are having an is having a higher or doing much better compared to the another states, and you want to bring out their distributions, and then you can also look into is there any special grouping or grouping of those well-doing classes or well-doing states compared to other ones. Same way in this case, as we can see that at the core of the city we are having a 5% or the two standard deviations population density. As you move away, we are seeing that the population density is going from middle to lower population density, and as you move outside, so there's this below to standard deviation population density. So that brings out that how the population is actually distributed, or there is a kind of disparity in the distribution of these data sets or population density, which is quite visible in this case. So if your objective is to highlight the disparity across geographical areas, so in those cases we can use the standard deviation classifications. The series classifications, this is just an example of geometrical series classifications which we can use it. So just to show that how the population density is increasing in from the center to the core and so on. So those kind of series classifications can be shown in this case. It's basically to, because you in this case it is expected that your population density is not linearly increasing from the core of the city, but there's a kind of geometrical progression relationship is existing, and that particular fact is being established with the data representations in this case. So generally there might be a questions that how to decide which particular classification scheme should be used. So this is just an slide which gives you the idea about that how the classification should be done. So in this case, if you look at the histogram of your data sets, and if it matches to an appropriate series, for example, if it is a straight line that is being shown as an S, so then you can say that you can go for a linear or equal interval classifications. So that can be used like in this case. But if you're having a distribution which goes above that straight line or the diagonal line, and then after from the middle again it goes to the bottom of the line and so on, so in that case what you can consider it that in those cases you can go for a natural classification or natural classification distributions and so on. And if your distribution of your histogram, that above histograms looks like the way AGR, which is arithmetic, geometrical, and basically the reciprocal representation of the data set, if it is matching to that particular histogram, then you should go for those series based classification scheme. So your classification scheme should be based on the attribute histogram distributions, and accordingly the classification scheme should be carried out for exploratory analysis. So this is just an example of population density per square kilometers, and as you can see that the geometrical progression is giving you much better representations in terms of data sets compared to other classes. So this is for exploratory in nature, but if you are having a very specific purpose, then you can pre-decide which particular classification scheme should be used, and that should be used. But if you're in exploratory mode, you don't have any well-defined objectives or goal, then in those cases you can do you can start looking into the distributions, and based on that you can make few hypotheses. So based on your effect, based on your classification, your histogram data sets will be grouped into different group, and accordingly your data representation will be different, so which is being shown in this case. So your classification scheme becomes an important tool to represent your data sets, and that should suit or that should match to your the objective, and accordingly it should be chosen and should be done. Each of those same information, but the way you have carried out the classification or the grouping of the data set, their representation becomes quite different, and each of them represents different kind of view of the same data sets. So with this we are going to end the session over here.